Thanks for the great introduction, for the great segue for my presentation. So once again, my name is Iurii Milanov. I'm a director of AI and data science practice here at Softserve. And just to elaborate a little bit on the Ron's introduction, right? So we are IT services and digital advisory company. We are 27 years old. As Ron said, we are almost 10,000 people large. And we've been premier partner with AWS for many years. We hold a number of competencies or specializations, if you will, including machine learning, MLOps, data analytics, DevOps, you name it, right? But what essentially we do, we help our customers validate their quite ambitious ideas, right? And build a full-scale production-grade solution on AWS around those ideas. And some of our key focus areas are artificial intelligence, right? And the way to use these powerful technologies to enable new business models, new features, new customer experiences. Advanced analytics as a way to use similar technologies, but to get a better understanding of the business, better understanding of what is going on inside your product, right? Get some actionable insights. Intelligent automation as a way to automate routine or maybe challenging task, right? Whether it's a business problem or maybe it's an industrial automation. And finally, we are expert in building reliable infrastructures and processes that allow to build this powerful ML solution in the most efficient way, which we call MLOps. Right, so quick recap of the agenda. So I'll start with the question, why AI machine learning? I assume many of you are familiar with what it is, right? But just to get everyone up to speed, I will quickly recap why do we actually need these technologies, right? From there, I will go into some of the challenges and best practices, right? Why is it still difficult to use these technologies to apply them to the real business problems, right? Finally, I'll show how Sagemaker can significantly accelerate this process, right, and solve some of the most critical problems in this process of building this type of competencies and the application. And I'll share some of the key stories how we help our customers solve their business problems using Sagemaker in the most time and cost efficient manner, right? And finally, if we have time, we will also have a Q&A after my session. All right, so why machine learning, right? So I'd like to start with this a bit speculative picture, right, that compares different computational and biological systems from the number of neurons standpoint, right, from terms of capacity of intelligence, right? And as you can see, as a technology, we are still far behind of what is called general intelligence, right, or human intelligence. But in the same time, as let's say frog's eyesight can outperform humans in some narrow circumstance, in a similar manner, a specialized neural network or machine learning model can outperform us in a specialized task like identifying objects on the images, right, or understanding the natural language, driving cars, or even playing games, right? And the problem is that many of these problems, they actually multidimensional, highly dimensional, right? Think of the language, right? So let's say you want to do some sort of sentiment analysis, right? Maybe on the Twitter data, and apparently there is infinite numbers of ways how to say good, bad, and neutral things, right? You just cannot use traditional software engineering to hand code each and every of them. And even if you can, it will not scale, right? The language kind of, it's dynamic, right? And this is why, and this is when machine learning comes handy, when it actually shines, right? So if we continue this analogy, in case of traditional software development, there is a developer, software engineer, or ourselves writing a solution for a problem. In case of machine learning, there is an algorithm, right, that learns a solution from the data and produces the code in a form of model. So they are quite similar, right, in their nature, right? Although the problems that we used to tackle with machine learning, they're quite different. And this created an entire kind of concept of machine learning being software 2.0. And here you can see the quote from Andrew Karpathy, who is the head of AI at Tesla, who mentioned that gradient descent, which is a method that is used to train modern neural networks, can write a better code than us, right? And he's sorry about that. And apparently, to some extent, that's actually true, because in order to to build a solution using machine learning, you need to know much less about your problem, right? Because your goal is to learn the solution from the data. You can scale your solution, its performance, its accuracy with the new data, right? And although it's quite hard to understand what kind of insight, what is the knowledge inside their model that you learn, but still there are ways how to relatively easy evaluate and make sure that the model performs, predicts in the way that you expect it to predict, right? And finally, there are many different applications for machine learning, even outside of traditional artificial intelligence. People are using it to do some low-level assembly code optimization and so on and so forth. But let's quickly take a look. What are the biggest some of the biggest breakthroughs that we have on the market? So let's say AlphaFold, right? The team at DeepMind used machine learning to solve a critical task in genomics unfolding, the gene unfolding, right? Which is a huge breakthrough, not only for AI machine learning, but for entire industry of genomics, right? GPT-3, unreasonably high-performant language model that was trained on terabytes of data that can generate the texts and solve many different language-related tasks at the almost human level. Deepfakes, you've seen them everywhere. And there are many different applications of AI machine learning that aim to solve different type of games, let's say Atari games, or playing against world champion in Go, or even playing StarCraft, right? And you can form your problem in terms of many of these kind of larger problems, although the real problem, they usually much harder than those. But what are the challenges, right? Why don't we have machine learning everywhere, right? And why even doesn't matter whether it's an enterprise or a startup, why it's still difficult for companies to use these technologies for their problems. And to illustrate this process, I want to walk you through quite a typical anecdotal story, right? So let's say we are starting our machine learning project, right? There's usually a data scientist, quite ambitious with a PhD in mathematics. There is a business, right, that needs some problem to be solved, and there is IT representative, right, that provides the infrastructure for everything related to digital for this company, right? And let's say business asks the team, right, whether we can use machine learning to improve our customer experience. And of course, the data science will answer yes, but I'll need to analyze all the data that we have internally. I may need to use some of the third-party data, and I will need to run a number of experiments, right, using my scientific toolkit. And then an IT person will come in and ask, okay, but how do you want to run your analysis? Do you want to run it on your laptop or on the cloud? What are the compute resources that you will need, right? Because you might be dealing with some terabytes of data. How will we integrate your solution to our application? And moreover, what kind of data you will need? How will you access this data? How will we deal with all the security and regulations, right? There is a number of questions that an IT representative may ask. The business representative will follow up on that. Okay, and how can I consume this result? How can I analyze the insights, and whether we can actually trust those results? So you can see this is just the first conversation around AI machine learning. There is a number of questions that need to be answered, and no one has answers to those questions. And this is quite a typical story, right, that leads to failure of many different projects, and we've seen it all over the kind of different businesses and industries. Right, and apparently the Gartner survey that they made a couple of years ago proves this kind of this problem, right? That according to their survey, right, more than a half of the machine learning models that were developed were not actually used or deployed to production, right? And if something was built and never consumed, there is no value in any of the AI proof of concept or whatever solution you build. It should be used. It should generate the value. How can we tackle this problem, right? What are the best practices, right? Because we still see huge value in these technologies, and many companies use them quite successfully. So in order to understand this, we need to kind of switch our perspective. Machine learning problems, they're quite different in their nature, right? So when you think of the journey from experiment to production, it starts with a business understanding, right? And there's usually a team that communicates with the business, trying to understand what are the objectives, what are the needs, right? What are the requirements, what are the constraints, right? What kind of value it will generate, what will be the success criteria. And from there, the team starts experimenting, right? Collecting the data, analyzing a training model, comparing different results, and maybe after a couple of iterations, there might be a solution that itself might be ready for use in production, right? But there is a room for improvement. That intermediate result can be picked up by the engineering team to operationalize it, deploy it, and make it available for users to consume the results. And what is also important is to be able to measure the incremental impact of the machine learning solution that you deploy, right? How people are using it, whether there are any anomalies in the predictions, right? Whether the new model that maybe your data science team made a couple of more iterations and build a better model, right? Can we prove that that model not only better on the tests set, right, during the evaluation, but also better in production? It's quite important to have that reliable infrastructure, and that those results, they inform the further ideation, further experimentation, so on and so forth. Machine learning solution is never done, right? And it's an infinite and continuous process. Moreover, it requires quite a lot of engineering efforts and collaboration of multiple teams, DevOps, data engineering, software engineering, data science, right? And those worlds, they usually speak different languages, right? It's hard to find the common ground between all those teams. So what we actually need here is quite similar to what we actually already built for traditional software engineering. We need a process and set of best practices that will allow us, right, to continuously improve the solution that we are building, right? Test it and deliver it in a reliable way to production, to the end users, but also be able to monitor it, be able to understand how can we do better, right? And then again start a new iteration. We in the modern world we call it MLOps, right? Some people call it ModelOps, but the idea is similar all over the place, right? So what kind of things it enables? Fast iterations from idea to production, focus on the experiments instead of the infrastructure, and it significantly accelerates the process and provides transparency and trust to the solution that you're building. Luckily, Amazon provides quite a powerful tool, which is almost a one-stop shop for this type of problems, right? Amazon Sagemaker is a set of tooling in an entire infrastructure built to solve almost every task along this process, right? Starting from the preparing the data for training, whether it's labeling or collecting and transforming the data from some data sources, building different type of experiments, trying to use whether automated experiments using AutoML or maybe some custom models, train them on a large scale infrastructure using the environment and the tooling that data scientists are familiar with, but at the same time be able to expand those results to broader scale and apply it on a much broader set of data, right, and use it in production setting, right? And once again, it's a tool that solves almost every single problem along this way. But of course, you always want to do more. You want to do better, right? You want to have more control. You might have some specific requirements, and in that case, Amazon AWS provides a wide range of services that you can use to expand beyond SageMaker, right? You might have a number of your data sources and some ETL process that collects all the data that you need for training, store it in some what we call a feature store, which is centralized storage for all the data that is used for machine learning, and so that you can sort of trace back your model prediction to the specific data that was used to train the model that made that prediction, right? You can integrate some prepackaged APIs. You can monitor your solution using CloudWatch. So there is an entire ecosystem that you can gradually leverage, right? But a SageMaker provides you a number of tools out of the box, so you can quickly start and get your solution up and running, get your users use and consume the results of your model, right, while you are building a broader infrastructure around. And to illustrate you this process, I want to show you two different success stories from the customer that we work with, right? So one of them is one of the biggest worldwide manufacturing companies, and they essentially what they wanted to be a solution that will allow them to assess the level of risk across their supply chain, right? Because let's say you want to manufacture a product, there is a number of parts that form that product, and the shortage of a single part may impact the entire product, right? And how can you predict that in advance, right? How can you forecast both long-term and short-term risk associated with a specific part, a specific product? And if you think of a manufacturer of this scale, you can imagine how many products do they produce, right? Like how many parts are there, and predicting on that scale is extremely difficult, right? It requires a lot of resources and a lot of power, and it's quite hard to build a solution that will tackle such a big problem. So what we actually started with this customer, we started with collecting the data and understanding what kind of data can be used, right? While we were doing that, data science team was already looking to that data and started experimenting with trying to formulate the problem in terms of AI and machine learning, right? Whether it's a survival analysis for long term, for forecasting, right? Or maybe just a time series forecasting for short-term risk, right? While that infrastructure was building, data science team built a number of models that were already prepared for that data for coming, right? And from there, we using Sagemaker, we were able to build two different prediction pipelines. One would be the batch scoring pipeline that processes millions of components and produces long-term predictions for all of those components. But another one is a live inference pipeline that for a given bill of material predicts the risk for each and every part to be short for this particular purchase order, right? And everything was, and we didn't have to put any additional code into our solution. Everything was provided by Sagemaker itself. So if you think of it from the architectural standpoint, right, there are a number of components that are used in addition to Sagemaker, right? Like we build up the ETL layer that uses databases and RDS and S3 data to feed into our model training pipeline. We've done a lot of orchestration using AWS step functions, right? We use Sagemaker for as well for scoring and prediction, right? But we also use CloudWatch to monitor the prediction, maybe trigger the retraining pipeline if you see that the accuracy of the model drops over the time. So once again, what we were able to deliver using Sagemaker, so it's a solution that enable our customer to quickly get the risk assessments for whether it's a long-term or short-term, right? They are able to predict the unexpected events in advance, but they are also able to simulate different scenarios, right? Let's say if the Bluetooth 5.0 arrives, right? How would that impact the market, right? So, and how would that impact their supply chain pipeline? Another story is a completely different type of customer, right? They're a small-scale startup company who are developing a product for personalized competency-based learning for corporate sector, right? And they have essentially what they are doing there. They define the competency model that itself relies on the number of activities that a person should take in order to achieve that competency, right? But given the scale of the market and scarcity of the market that they deal with, every given customer, they had to actually perform this analysis manually, right? Define those specific activities that should be taken to accomplish certain competencies. What we built for them is actually a solution that is able to take those competency descriptions and map to the entire database of different books, articles, online courses, and so on and so forth, and essentially automate that process of building the learning path for a given learner, right, for a given student, right, without any additional, without any manual effort. And this process can be done either automatically using some API communication or manually if a person wants to see more control, right? We also were able to use some of the pre-trained language models that allowed us to accelerate this process and use much less training data, right? And we were able to build this entire solution in a matter of 2 months for this customer, right? Started from the idea all the way to the production grade solution that was integrated into their application.
So this is another example how company of smaller scale can quickly leverage SageMaker and get the problem that they care about solved as fast as possible. So quick summary, scaling AI experiments, right, from the initial success to a production grade solution requires lots of engineering components iterations, and success of this type of initiatives depends on the cooperation of multiple teams and groups of stakeholders. And once the solutions are live, they're not done, right? There is always a way to improve the model with the new data, and it's important to be able to constantly monitor and check the quality of the prediction and be able to debug critical issues when they arise. And the SageMaker provides a wide range of different tools and infrastructure that allows you to exactly what I've just described, right? Starting from the initial experimentation all the way to the full-scale production grade model that you are able to monitor and understand how does it perform over time, but also interpret some of the critical issues that may arise. And right now we consider at Softserve SageMaker as a primary infrastructure for almost as a default infrastructure for almost any project that we start with our customers. All right, so I hope you found this content relevant and interesting. I really want to say thank you everyone for your time and attention. I really appreciate it.